This is chapter 4.8, exercises 11 through 16 and 19 through 22. This set of exercises has to do with finding real-world applications of trigonometric ratios, in this case distances. Problem 11. Now, this problem is similar to ones we've worked earlier in the last video lesson that covered problems 1 through 10. One thing we have to do is be sure that our calculator is in degrees mode. I'm going to do that. Just go here and pick the sign of 90 degrees. If we're in degrees, our answer will be 1. It is. We are in degrees. Problem 11. A guy wire attached to the top of the KSAM raised antenna is anchored to a point on the ground 10 meters from the antenna's base. The wire makes an angle 55 degrees above ground. How high is the KSAM antenna? And so we get a level ground that I represent here. And we're going to build from that an antenna. The antenna, I'll just make it kind of like this. And so it has a antenna looking ladder steps there, whatever you call it. All right. Anyway, so that's our antenna. And we have a guy wire. Well, guy wire is a wire used to attach to a structure as a support. Otherwise, against wind and so forth, the antenna wouldn't be able to buck much in the way of forcible winds. So this angle with the ground is 55 degrees, and we have the distance that the wire is anchored from the base of the antenna is 10 meters. There it is, 10 meters. And then our height, we do not yet know. So we're going to determine our height. And if we look at the ratios, we have our 10 meters at the bottom is going to be the adjacent side, and opposite the 35-degree angle is the height, which we do not yet know, which we'll call opposite. So our trigonometric ratios that involve the adjacent and opposite sides are these. We have the tangent of theta is equal to our opposite over or divided by our adjacent side, and our cotangent theta is the reciprocal of tangent, which will be accordingly our adjacent side over our opposite side. In this case, the tangent is going to work out better, and we will say the tangent of our angle, which is 55 degrees, is going to be equal to our height, which we do not yet know, over our adjacent, which we do know. And why is this a better thing perhaps than the cotangent? Because the cotangent of 55 degrees is going to be equal to the reciprocal, or 10 over h. So the algebra is just a little bit more, a couple more steps involved. So we'll just stick with the tangent for now. And so if we take this, multiply both sides of this equation by 10, which is the same as cross multiplying by 10, because 10 over 10 cancel on the right side, and what we have left is the height is equal to 10 times the tangent of 55 degrees. And we can just go to our TI Inspire CX calculator. So 10 times tangent of 55 degrees. And we get 14.28. This is meters. So I'll say height is approximately equal to 14.28 meters. And that answer should make a little bit of sense in that our adjacent is 10 meters, so we're going to have more than that adjacent height. So it's going to be about, feet, about 45 feet or so. Okay, next, this problem 12, we're going to have to take this angle here in DMS and convert that angle into just regular degrees, which we take our minutes and divide by 60. And so when we work this all out, we're going to get 29.75 degrees. Okay, I'm not going to work out any more of problem 12 than this. Let's go on to 13. The Pos Verde, a whale watch boat, is located at a point P, and L is the nearest point on the Baja California shore. So here's the boat here. And if we go the shortest distance to the shore, that's this point L, from P to L. Point Q is located 4.25 miles down the shoreline, and PL is perpendicular to LQ. So that's designated by this right angle rectangle here. Determine the distance of Pos Verde is from the shore if angle PQL is 35 degrees. And so that's what we want to know. We want to know this distance right here from the Pos Verde to the shore. Okay. And what we have is, I don't know if you can easily recognize this, but this is another tangent application. Why is that? Well, we have 4.25 is our adjacent side, and opposite our 35 degrees is our unknown distance. Now, if we look at problem 11, we have the bottom side of the triangle is the adjacent. Here, the top side is. Well, it has to do with where the angle of incidence is we're looking at. Here, it's kind of turned upside down. And so, try not to be disoriented. And so we know that the tangent of this angle, 35 degrees, is equal to our distance from the shore over 4.25 miles. And similarly to how we did in problem 11, if we cross multiply this 4.25 over here, we're going to get our distance equal to 4.25 times the tangent of 35 degrees. And going to our calculator, we put in 4.25 times tangent of 35 degrees. So we get 2.9758. We'll call it rounded to the 3 figures. We'll call it approximately 2.98 miles. So here we are, distance is approximately equal to 2.98 miles. Now we're going to go on to the next odd number problem, 15, but before I do that, we're going to go into look at 14. We have this problem here. Well, this problem here, 14, I'm just going to kind of draw a little picture of it because you have this mountain up here. Draw this weird looking mountain, and you have a level trail here, and you have this guy named Otis who's hiking along, and so he goes 1,000 feet closer to the mountain, and his angle of incidence here, if you want to call it that, changes from this 30-degree angle to this 35-degree angle. And so you can set up it really ends up being a system of equations. You have this, you can call this distance here, x, well, I'll go right here, x, we'll go right underneath the peak, and this other one, you can call this one x plus 1,000. So anyway, that's you end up having two triangles, ends up being a system of equations. Well, good luck with that one. Let's go on to 15. The angle of elevation from observer to the bottom edge of the Delaware River drawbridge observation deck located 200 feet from the observer is 30 degrees. The angle of elevation from the observer to the top of the observation deck is 40 degrees. What is the height of the observation deck? So we have two triangles. We have one that I'm outlining here in red, and this is one where we have tangent again, because we want to find this height here, and then we want to take another triangle, and now I'm now sketching it in green, okay, and so we want to find this second, which I call this green H, to the top. And then when you find this green H, which is the distance to the top of the observation deck, and this red one down here, and subtract them, then you have the height of the observation deck. So let's go ahead and do this green one first. We have the tangent of 30 degrees is equal to the height, I said with red height, I'll just make it red here, over 200 feet. So cross multiplying the 200, we have height is equal to 200 times the tangent of 30 degrees. And then for the other triangle, the green one, we have the tangent of 40 degrees is equal to this height over 200. So we can go place both of those calculations. Before the calculation, let's just work out the, okay, we did that first, and work out that second equation. We have green H equals 200 tangent of 40 degrees. So we have, and then our true height is going to be H minus H, right? That's going to give us the height of the deck. So here we go, back to the calculator. We have 200 times the tangent of 30 degrees, and we have 115.47. feet. And for the green one, okay, we go here, we have 200 times the tangent of 40 degrees, and we get 167.82. So we'll say H 167.82 feet. And if we subtract these, we have 167.82 minus 115.47 feet. We're going to get our answer. And that's going to be this number here, control ANS, minus 115.47 feet, and we get 52.35 feet. Let's put that in here. So height of deck is, you put approximately equal to, but we'll say 52.35 feet. That's going to be our answer here. Problem 16. Problem 16, I think, is going to come out sort of like 14, in that you're going to have two triangles here. This one right here, you can call this one X, and how far does a car travel? Well, we don't know. We can call this Y over here. But you're going to come up with two triangles similar to how you had a problem 14, and be able to determine this Y minus X. It'll be a system of equations. 19. Next item of problem. The angle of depression is 19 degrees from a point 7,256 feet above sea level on the north rim of the Grand Canyon level to a point 6,159 feet on the south rim. How wide is the canyon at that point? And so what that looks like is, you get this north rim sitting up here, and then you go down into a canyon, the Grand Canyon. You come here and then have that pick up that south rim, right like this. And so you're interested in this, and it says how wide is the canyon at that point. And so you can interpret the width being like the horizontal distance, but since that's really kind of a matter of judgment, I am going to rather call our direct distance, or how wide the canyon is, a direct line of sight here, which is going to change which ratio we use. But this height at the top is going to be 7,256 feet in elevation, and at the south rim you have 6,159 feet. Well, what you have is, how do you find out and make sense of that? Well, what you have is, this creates the height of this shape here, because the height is going to be this 7,256 minus this 6,159. Okay, so 7,256 minus 6,159. Okay, so now what that's going to be is, it's going to be 16 minus 9, which is 7. And this 5, well, we are going to have to borrow, because we don't have enough right here. We had to borrow from here to create 1, so we got 4 here. And if we borrow 1 from here, we get 14. So 14 minus 5 is going to be 9. And then if we go ahead and take this 1 minus 1, we have 0. And then 7 minus 6 is 1. So we have 1,097 feet in elevation difference. So that's going to be this distance here, 1,097 feet. We want to find the direct distance. Well, let's look at our angle here. Our angle is 19 degrees. So we're going to say this is a 19-degree angle right here. And if we draw from here 19 degrees, we go to the opposite side. Our 10,097 feet is our opposite side, and we will call this width here in blue, we will call this the hypotenuse. And we don't know what it is. But the sine of theta is equal to opposite over hypotenuse. Well, in this case, if we use our cosecant theta is going to be equal to our hypotenuse over our opposite side. And we're going to want to use the cosecant. Why? Because our hypotenuse is really our unknown. So we will say the cosecant of 19 degrees is equal to our hypotenuse, which is the width of our canyon, over this opposite side, which is 1,097 feet. And cross multiplying the 1,097 to the other side, which we designate here. Okay, there it is. We have hypotenuse is equal to 1097 times the cosecant of 19 degrees. If we go to our calculator, we have 1097 times the cosecant of 19 degrees. So we get 3,369 feet. That'd be round to the nearest foot, almost 69.5 feet. We'll call it 3,369 feet. Okay. Let's see that just to be sure. Yeah, that'll be it. So we'll just box this in as our correct answer for the width of the canyon. And again, if you'd use this horizontal distance, you would get a number slightly less than 3,369 feet, but not much. Because with these small angles, like something like 19 degrees or left, the hypotenuse is going to be pretty close in length to this horizontal side, or adjacent side in this case. Next, again, problem 20, we have DMS. We have to convert this 1 degree 20 minutes into DMS. I think it ends up being like 1.3, 1 1/3 degrees. Anyway, let's look at this one, 21. Bearing of the line of sight to the east end of the Royal Gorge footbridge from point 325 feet due north of the west end of the footbridge across Royal Gorge is 117 feet. What is the length L of the bridge? Well, this is one where you have the end of the bridge is down here. And we really want to find this interior angle. Well, what that is, that's a supplementary angle. And so we want this angle here that we really want, we're going to call theta, is going to be using principles of supplementary angles, 180 degrees minus 117 degrees. And that's going to be equal to 63 degrees, I believe. Is that right? Yeah. So we will say this angle here is 63 degrees. Doesn't much look like a 63 degree angle, but we'll have to go with it. And really, we're dealing with a tangent again, aren't we? Because we have our 325 feet here as our adjacent side. Our length over here is going to be our opposite side. And so just working that out, we have the tangent of 63 degrees is equal to our length of our footbridge over 325 feet. And cross multiplying, as we have done just about everywhere here today, we have our length of the footbridge is equal to 325 feet times the tangent of 63 degrees. So let's go do that. We have 325 feet times the tangent of 63 degrees, and we get, looks like round the nearest foot, we'll call it 638 feet. 638 feet. So that was approximately 638 feet. That's the length across the bridge. So then looking ahead at 22, 22 is very, very simple. And it looks like a tangent sort of deal. Now in this exercise set, the more challenging ones, 14 and 16, we did not do, but I kind of set those up a bit, so good luck on those. And everything else. And as always, thanks for viewing.